Okay, let's go over practice exam 1, problem number 5, part B. Right, so we want to take the limit of this function cosine of x over x squared, which is fairly involved function. So what we're going to do is this. We're going to try to use a squeeze theorem to evaluate this limit. Right, so we know that cosine function cannot be very big. Cosine is always between -1 and a +1. Right? So it's always between -1 and +1. All right. Then we can use these inequalities to find the smallest function and the largest function, right? By dividing through by say x squared. Right, so x squared is negative, so we don't have to worry about the change in the direction of the inequalities. So we have negative 1 over x squared is less than or equal to cosine of x over x squared is less than or equal to 1 over x squared. Right, so you can see that this is the smallest guy, and the middle guy is the guy we're interested, and the larger guy, right? So instead of looking at the middle guy directly, we're going to take the limit of the smaller guy. So we're going to look at the limit of negative 1 over x squared as x approaches infinity. All right, but this one is actually fairly simple. All right, so you have a negative sign here. All right, then you have 1, right? Then infinity squared is still going to be infinity, so you have infinity, right? But the 1 divided by infinity is going to approach 0 because you're dividing by a huge number, so it's going to be -0. Well, you can just say 0. All right. Then let's look at the larger guy. So if you take the limit as x approaches infinity of positive 1 over x squared, right? Same as before, it's going to be 1 over infinity, so it's going to approach 0, right? So therefore, by squeeze theorem, if the smaller guy goes to 0 and the larger guy goes to 0, the middle guy has to go to 0 because there's no other place to go. So you can see that this limit is going to be 0, and this is by squeeze theorem. Okay, that's it. I hope that this was clear.